Okay, everyone, we're going to start on our 5-3, which is the last lesson of this unit. And we have also, always been talking about exponentials from the start of this unit and actually in the last one. So we talked about how we graph an exponential, how we write an exponential equation. In 5-2, we talked about transformations, how it shifts around the graph, up and down, left and right. And now we're going to put it into our last component, which is a real life scenario. So you guys are always asking me, when can we use this in real life? And this is an example of when we use exponentials, okay? This has to do with growth and decay, or increase and decrease. And it's talking mostly about the value of things in real life. Like if you have an investment in a bank or you buy a car and the value decreases. If you put in money in the bank and savings account and it has a percentage rate and it increases each year, how much money will you have at the end? Those types of things. So we're going to be talking about two different types with exponential growth and decay. And then we're going to, at the very end, we're going to talk about compound interest, which is something that you always use for your investments at the bank as well. Okay. So getting started, exponential growth obviously occurs when something increases over time. So you see this part up here that says increases for growth. Okay. We kind of already talked about that a little bit. This is your formula, and you are going to have to memorize this formula as well as the decay one, and the compound interest one I'll give you on the test. But this guy, f of x, and you kind of look, it's the same exact thing that we've been talking about. It's a, and then b would be this one that we're multiplying by to the x. So it's kind of the same thing. A is your initial amount, which would still be kind of like considered your y-intercept, the starting amount, okay? R is your growth factor or your percent. This has to be written as a decimal. So if they give you a percentage, you have to change it to a decimal before you can start, okay? And we'll talk a bit about how to do that if you've forgotten. Time in years, sometimes you're going to have to convert this from months if it's needed. If the entire problem is talking about it in a certain time span, then you don't have to convert it. You have to pay attention to what it's talking about, okay? This part in here for the growth, every single time, if you notice, this is 1 plus the rate. So every time you write this down, it should be a number greater than 1. We talked about that with growth, and we always said that you can tell it's a growth because your b value is greater than 1. This is the same thing. Once you create or calculate your growth factor as a decimal and then add 1 to it, it should obviously be bigger than 1. So if you end up with a smaller number or a regular fraction or a smaller decimal than 1, you know you have to add that 1 to it. So make sure that you're paying attention to that. Okay? All right, let's do our first one. The original value of an investment is $1,400, and the value increases by 9% each year. Use an exponential growth function to find the value of the investment after 25 years. Okay, so again, we're just plugging in to our exact equation every time. So we have a times 1 plus r to the x. Okay, a is our initial amount, so that's the $1,400 that we invested in there. Okay, the value increases by 9%. So 9% as a decimal. Remember the decimal points here, and you go left, 1, 2. So this becomes 0.09. Okay, so I'm going to put in here 1 plus 0.09 to the x. That's our function, right? Okay, now if I add these together, I get 1,400 times 1.09, so it's bigger than 1, so there's our function for that. And we know that this is going to happen for 25 years, so that's the value that goes in for x to the 25th power, because it's happening 25 times, okay? All right, so for this part, you're just going to type it in your calculator from left to right. So starting here, 1,400 times, and use the parentheses, 1.09 to the 25th. If you type that in, f of 25 to the 25th would be $12,072.31. So you have to have your calculator handy. We're going to need it for every single one of these. I want you to practice typing them in. Okay? So obviously it went up from 1,400 to 12,000. So it increases. Make sure every time that you're looking at that to see if it actually matches what you said it was going to do. Okay? Let's do our next one. So we've got annual sales for a company are $149,999 and are increasing at a rate of 4.5% per year. Use an exponential function to find the annual sales after 7 years. Okay, so again, here we go. I'm going to have f of x equals a, my initial amount, so 149,999, right, times 1 plus, because it's increasing, 4.5% as a decimal is 1, 2. So it's 0.045, right? And then to the x. Okay, again, if you wanted to add these together, you get 149,999. 1 plus this would be 1.045, which is bigger than 1, right? And then 7 years means I'm plugging in a 7 up here for my x. You have to multiply all the way through, so type this whole thing in your calculator. And when you do, we should get an answer of 204,127.91. Obviously an increase. Okay, so again, checking to make sure that's right. Okay, so that's an increase. The only difference between increase and decrease is in the formula. So when you see an increase, you're going to put 1 plus a number because it has to be greater than 1 for our b value. And in this one, you're going to see 1 minus the number. Well, that's because it has to be smaller than 1 when it's a decay. Everything else is the same thing. A is the initial amount or the y-intercept. Decay rate as a percent has to be changed to a decimal. Time is in years. Everything is the same. But the number is going to get smaller because you're multiplying by a number smaller than 1. Okay? So, first one. A farmer buys a tractor for $50,000. If the tractor depreciates, which means decreases in value, 10% per year, use an exponential function to find the value of a tractor in 7 years. Okay, so here we go. Same thing. F of x equals a, so $50,000 is what my tractor starts off at, times 1 minus, because it's depreciating, 10% as a decimal, 1, 2. So it's going to equal 0.10 and then to the x, right? So for this one, we're going to have f of x, equals 50,000. Okay, 1 minus 0.1, like $1 minus 10 cents is 90 cents, so 0.90. And then we're happening for 7 years, so 7 goes on the outside. Okay, again, this should get smaller when you type it in from left to right. So 50,000 times 0.9 to the 7th power. Okay, so for 7 years, after you buy your tractor, it's going to be worth $23,914.85. Obviously, a lot less money. We all know that value of cars and vehicles goes down as soon as you drive them off the lot. So this is an example of how fast they depreciate. Okay, let's go to the next one. The population of Campbell County, Kentucky has been decreasing at an average rate of about 0.3% per year. In 2000, its population was 88,647. Write an equation to represent the population since 2000. If the trend continues, predict the population in 2010. Okay, a couple different things happening here. So Again, it's decreasing, so we know it's going to be 1 minus in our b value. So I've got f of x equals, my starting amount was 88,647 people, 1 minus. Now, this is already a decimal, but that doesn't mean anything right now. We still have to change it from a percent to a decimal value. So we still have to go 1, 2. It's a pretty small percent, which means it should be an even smaller decimal. So 0.003. Okay, so 0.003 to the x. Okay, so if I subtract here, we're going to have 88,647. 1 minus 0.003 is 0.997. Okay, so I have that part. Now, the difference here is we can't put 2010 because it's not happening for 2010 years. It's only happening from 2000 to 2010. So we have to take 2010 minus the year we started, and that only equals 10 years. So 10 is going to be what you plug in here. Okay, you're going to have to pay attention to that. You can't just plug in the number it gives you every time. All right, so again, this should be decreasing, small amount because it's 0.3% each year. So if you type this in from left to right in your calculator, we're going to have that the f of 10, the function of 10 years, gives us 86,023. Okay, and I put a dollar sign. Whoopsies, didn't mean to do that. This isn't dollars, this is people. Okay, so it did go down, but this would be a small amount for 10 years because it's only decreasing 0.3%. Okay, all right, so that is increase with growth and decrease with decay. And you will, again, have to memorize that formula. But think about it for a minute. It's not that much different. Instead of just putting in b, we are putting in 1 minus the rate or 1 plus the rate. Bigger than 1, smaller than 1. Okay? Now, the last part of this is called compound interest. Okay? It's a little bit more involved. And you're going to see that the formula asks you to do a little bit more, which is why we're going to give you this formula for the test. Now, the one thing you won't have is this explanation over here about what everything means. So I'll write this guy on the board, but you have to know what every part of the actual formula stands for, okay? So compound interest is paid on both the principal and the interest that has already been paid. So when you invest money into a bank, you're earning money back on that investment, not only on the amount you put in, but the amount that the bank is paying you interest on. So it's compound interest is the best kind. It gives you the most bang for your buck when you're trying to invest money. Okay, so A stands for the amount you paid. Okay, so that means like the amount you're paid from the bank. So this would be like your profit, not what you paid in. Okay, so I'm going to put in here your profit. Principal amount is kind of like that starting amount. It's kind of like our y-intercept. It's the amount you invested to start with. Okay. R is our rate of interest. And again, it has to be written as a decimal. N is the number of times per year that the interest is compounded. So number of times could be monthly. It could be quarterly. It could be semi-annually, or it could just be annually, yearly, okay? So monthly would be 12 times a year. Quarterly for a year would be 4 times. Semi-annually would be twice, and annually, of course, would be 1 time a year, okay? And then how many years it's happening would be our T, okay? And you can see N happens twice. You're going to take the rate divided by N, and you're going to take N times T. So how many years is it happening and how many times per year is that occurring? All right, let's see if we can get this taken care of. So Kimberly's family invested in a certificate of deposit, a CD, for her when she was born. The interest is compounded quarterly. So there we go. Quarterly means 4, right? What is the value of the CD at the end of 5 years? Okay, so here's our first one. We're going to take the formula up here and start plugging in what we know. So we're looking for A every time. So it's always going to say A equals, right? That's what we're looking for. How much money are we making off of this? P is your principal. Principal is what you started with. So we deposited $3,000. So 3,000 times 1 plus, because again, it's a growth every time if it's going to earn interest. Okay. My interest rate is 8%. So 8% is going to be 1, 2 with our decimal. So it equals 0.08. So I'm going to have 0.08 divided by N. N is the number of times it is compounded every year, which is 4. And then out here, I'm going to take 4N. So, and then times T. Well, it's taking 5 years. So times 5. Okay, I just plugged in something for every single one of these variables. And it gave us all the information. So it's not too difficult. It's just knowing what everything stands for. Okay, so you guys just need to be able to divide and put it all in your calculator. Okay, so I like to simplify this part first inside of here. So I have A equals 3,000. And then if you'll punch in 1 plus, okay, and then you're going to do parentheses 0.08 divided by 4. And we should get 1.02. And then I went ahead and simplified this guy. So 4 times 5 out here is going to give me to the 20th power. And again, this is bigger than 1, so it should see a growth. All right, and we're going to type this in from left to right. 3,000 times 1.02 to the 20th power. And this is going to give us that A equals, oops, I put my decimal, put that out there, is going to give us $457.84. So if you kind of look, he invested $3,000 and 5 years later, he's made a profit of it over $1,400 with not putting any more money in the bank. That's just the bank paying the investment. So it makes it a lot easier. Okay, now let's look at the next question. Will the value of Kimberly's CD be greater after 5 years if it is compounded annually rather than quarterly? Okay, well, we could do this math-wise, but if it's the same amount of time and you're earning less interest because it's only doing it annually, that means it's only happening 1 time per year versus 4 times per year. So this is a no. You're never going to earn more money if it happens less, if the interest happens less often, okay? So I'm going to put here no, because the interest is earned less often. Now, that's only because the year span is the same, right? If you leave it in for a different amount of years, like if this guy was in here for 20 years, that might be a different story because the longer the time, the more money you could possibly have to earn, okay? So same thing on letter C. What will the difference after 5 years be if the interest is compounded monthly rather than quarterly? Okay, well, we know the difference is going to be that the monthly happens more often and it's going to be more money, but it actually asks us to get that amount, okay? So this would be 12 times. This is only going to be 4, which we already know. So I'm going to put here, scroll up a little bit. I'm going to put here the quarterly amount, okay? So the quarterly amount that we got for our first answer in part A was $4,457.84. So let's do this again for monthly. So again, the original investment was $3,000. 1 plus our interest rate 0.08 over 12 this time because it's happening monthly. And then I'm going to take 12 times 5 out here. Okay, so if you just type that in from left to right, putting this guy in parentheses inside of there, okay, we should end up with, just keep getting that equal sign, $4,469.54. Okay, so quarterly is this amount, monthly gives you this amount. So then if you subtract them, you should be able to tell what the actual difference is. So we're going to take 4469.54 minus 4457.84. And I didn't have this done yet, so let me type it in too. And it's $11.70. Okay. All right, perfect. So take the bottom 4, use the formula, think about increasing, decreasing, and how often it's happening, right? Some of these are going to be from the front side, remember. So some of them are the growth and decay problems. It's only going to use this big compound interest formula if it tells you it's compounded interest. So this guy here, compounded quarterly, okay? Compounded monthly. That's going to use the big equation from this back side of the notes. If you aren't seeing those words, then it's just regular old increase and decrease, growth and decay, the 1 plus and 1 minus. All right? Let me know if you have questions on